Hi there. All right, so today we're going to look at rational expressions. And rational comes from the word ratio, and that's going to look like a fraction. So we're looking at algebraic expressions that are in fraction form, and we're going to just do all the operations, add, subtract, multiply, divide, these algebraic expressions. Now, before we jump in and do that, we do need to talk a little bit about the domain when we are dealing with functions. Now, we're specifically are going to be dealing with rational functions like this one right here. It's a algebraic expression in fraction form. But let's go back to just what we were doing the other day. We were doing polynomial functions. Remember that this is a cubic trinomial. And if you think about what you can plug in for x, because that's your domain, there's really nothing limiting what you could plug in for x. X could be a nice, pretty 4 number. It could be a 1/2. That's okay. It could be a -5. There are no restrictions in a polynomial function like that. And so we would say that the domain is -infinity to +infinity. Remember from Algebra 2 that the parentheses mean it can't actually equal that value, whereas if it did actually equal that, we'd use a bracket there. And in this case, infinity is not really a number, so we would definitely use a parenthesis anytime we write infinity. Okay, so now let's go to this next example. This one is a square root, and that's kind of what we're going to be getting into in the next few days, is doing some radicals. Now, think about this. We actually did talk about this a little bit the other day. What do you not want to have happen inside of this radical right here? This is called the radicand. And we would want to make sure that the radicand stays positive. So a nice mathy way of saying stays positive would be to say that that radicand, x minus 2, needs to be greater than 0. Now, can it equal 0? So can you take the square root of 0 if this was just 0? Sure you can. Square root of 0 is just 0. So I actually would change that to an or equal to. We add the 2 to the other side. And basically we're saying in order for this radicand to stay positive, x is going to have to be greater than or equal to 2. Now, I kind of showed you how to do it. Honestly, you could have probably done that in your head, and that's totally fine. It's just as that gets a little bit fancier, maybe this would be the process you'd have to go to. Now, we're still going to practice that interval notation. So when I see x is greater than or equal than 2, I'm thinking in my head, well, here's 0, 1, 2, and I want everything bigger than 2. It would look like this. Now, again, I'm showing you this one time. Futuristically, you're just thinking that in your head. So when we write this in interval notation, we're always going to write what the lower bound is, what the lowest it can be is, and that's 2, but it can equal the 2, so I put a bracket. The arrow shows that it goes all the way to infinity, so then the domain, and I should probably be putting a little d in front of here, these are your domains. This is what you're allowed to put in for x. We're going to come back to that radical one later on. But C is where we're really focusing today. We're looking at rational expressions. And think about this for a minute. Do you remember, what do you not want to have happen in a fraction? Right? You do not want your denominator to ever end up being 0. So I would say, again, you might be able to do this in your head. I'm just showing you how you would do it if it wasn't this easy. X minus 3 cannot equal 0, which means by adding 3 to both sides, x cannot equal 3. So that's my domain. Now, sometimes you're going to be allowed to just write it like that. In my math lab, it maybe will let you just ask you what can x not be, and you would just list 3. But in interval notation, that would look differently. To say it can be anything except 3, if you think on a number line, here's my 3, it cannot be a 3. But it could be anything bigger, and it can be anything less than that. So to write that in interval notation, it would look like this: -infinity all the way up to 3, but it can't be 3, so I'm going to use a parenthesis. In union with, and then you pick right back up at 3 again. 3 with a parenthesis to infinity. That's how you write that in interval notation. Now, keep this in mind as we're working through problems. We're going to have to be aware of that domain so that we don't accidentally go through this problem and end up, when we start solving and we find out that x is equal to 3, and that's our solution, because up here we said x cannot be 3. So if that were to happen, I'd have to write no solution because it can't be the 3. All right, so let's look at some simplifying of these rational expressions. Now, before we get started, notice down here that I say don't forget about the domain. So we are going to start by finding the domain of these. The reason we are concerned with the domain, again, is when we start solving. Now, we are not yet solving, but we're kind of practicing that skill of finding that domain. So when we get to solving, it's just second nature to be doing it. So I'm going to start off. I'm just going to write the domain off to the side here. Now I'm going to try to do this more in my head this time. If you look at your denominator here, you don't want this to equal 0. So I don't want this to be a 6. So that means I don't want x to be 2. So x cannot equal 2. And I'm just going to write it in that format. So then the next step is to actually simplify. Here is your big, big no-no. Looking at this 6 and this 12 and thinking, hey, I can reduce 12 and 6. That would just become a 2. Okay, no. When you're reducing and you're saying, oh, 6 goes into both and I reduce them, what I'm actually doing is I'm dividing them each by 6. Division undoes multiplication, and multiplication is not what's happening here. I'm subtracting the 6 and subtracting the 12 from what's here. So I am not allowed to get rid of them through division. So anytime you see the polynomial written like that, you kind of are thinking of it. It's its own thing all tucked together. This is its own thing all tucked together. And it can only cross off as a group. Now, what I'm going to do, though, nothing's going to cross off as it is, but I'm going to do what we did yesterday and practice some factoring. Now, I'm going to move pretty fast on our factoring today because we have spent quite a bit of time on it. I'm hoping you can factor by now. Factors of 12 that have a difference of 4. That's going to be my 6 and 2, positive 6, negative 2. In the denominator, I'm going to do a GCF. Factor out the 3. You're left with x minus 2. All right. So now, when you do this factoring, what you have created is some multiplication going on. See how this right here in between these two quantities is now multiplication. Between this 3 and this quantity is now multiplication. So I am allowed to separate those through division now. So when I see this x minus 2 here and this x minus 2, I can cross the entire grouping off because they are now being multiplied by something. So that's kind of our goal. We're going to factor and hope that we can find these quantities that match so that we can cross them off. Now, again, not allowed to cross the 6 and the 3 because the 6 is being added. I could only get rid of this if I got rid of the entire quantity. So final answer, all done, x plus 6 over 3. Okay, let's pick up the pace. Let's do this next one. A little bit harder factoring. That's okay. We can do this. I'm going to work on the denominator first for no particular reason. I'm going to do a 2x and an x. And then factors of 4. I'm trying to get this to add up to 9. So I'm going to put my 4 here, my 1 here. That's going to get me an outer of 8 and an inner of 1. That's what I want. Signs are the same. Both minuses. All right, in the numerator, I'm sure you're looking at that thinking, oh, I don't like the 12 to be on the front. I want the x squared on the front. But I actually don't want that because the x squared is negative. I don't want to start with a negative. So I'm going to leave it in this format. It's going to be fine. It's just that when you factor, instead of putting x and x on the front end, you are going to put your x and x on the back end. And that's totally okay. Now, because it's a negative x squared right here, that means that you're going to have different signs on those two x's. The factors of 12, I'm still going to be trying to get a 1 here. So I'm still going to be looking for factors of 12, going to end up getting me a difference of 1. There's a 4 and a 3. I want to end up with a positive 1, so I want to make sure that my 4x stays positive and my inner, my 3x, is going to be negative. Okay, now I'm looking to start crossing off quantities that match. And the only thing that I have that even looks close would be this and this, but these are not the same. This 4 is positive, this one's negative. This x is positive, this one's negative. So these don't match, but they're actually exactly opposite. So how about if we come up here on top and factor a -1 out of this one right here? Then it would be a -4 and a positive x, and that is what I have on the bottom. So I would be allowed to take this quantity and cross it off with this quantity now. But I'd still have the -1 sitting out in front. So my final answer will have that -1 out in front. And then the 3 plus x. Remember, this is gone now because I have it up above factored. And you could distribute your -1 if you wanted. It would be fine. Either way is okay. And in the denominator, I have a 2x minus 1 left. There we go. Okay, let's add to this. Oh, hang on. Time out. Wait a minute. I didn't do the domain. It says don't forget the domain, and I forgot the domain. Okay, so you have to figure out your domain at this stage, not your final answer, because you would have never made it to this stage without confirming that your domain at this stage. So looking back at this, and I say at this stage, I'm really going to look at my factored form. And so anything that would make this quantity equal 0 or anything that would make this quantity equal 0 is what I would not want x to be. So I'm going to say the domain on this would be x cannot be, well, the easy one is remember this was a -4 right there. So x I wouldn't want it to be a 4. On this, the 2x minus 1, this is what I'm doing. I'm going to show you here, but futuristically, I'm just doing this in my head. I don't want that to equal 0. So I'm going to add the 1, divide by the 2. So that would turn into a x should not be a 1/2. So that would be my other one up here. All right, it's getting fancier here. So now what I'm doing is I'm taking these two rational expressions and I'm going to multiply them together. Now, as we do this, I want you to kind of think, and I'm going to put it over here on the side. Remember how you multiply fractions. We're going to multiply fractions, something like if I had 4/9 times 2/3, you always multiply fractions straight across. That wasn't a great example. Hang on a second. I'm going to change it. I'm going to call it 3/2. I'm going to multiply straight across, but I'm always going to look to reduce things if I can. For instance, this 3 and 9 could reduce, and this 2 and 4 could reduce. All right, I'm doing the same thing over here. Again, not allowed to do just quick reducing here. I can only reduce after I've factored. So look at this. I got lots of factoring to do. I'm going fast through this on the factoring part because hopefully you're pretty good at your factoring and I don't want to slow you down. So I'm redoing it. This is a 2x and an x. I'm doing the numerator and then I'll do the denominator underneath there. So 2x and x. I'm going to be doing factors of 6. I want to end up with a difference of 1. So I am going to put my 2 here and my 3 here. Then my outer is a 4, inner is a 3. I'm going to make my outer be a +4, my inner be a -3. All right, denominator. This one's easier. X and x, factors of 5. Got to be 5 and 1. Signs are different. Let's do a +5 and a -1 so that we end up with a +4. Times. Now we're going to do the same thing over here. In the numerator, I can factor out an x. I'm actually going to sneak that out up here because I feel like that's not going to be the only thing I do. I feel like I'm going to have to then factor the leftover trinomial. So if I do that, if I factor that trinomial, it's going to be x and x. It's got to be 2 and 1. Signs are the same, both minuses. Denominator, let's pull out a 2x. And then I'm going to have, 2x minus 3. And now anything that's being multiplied is fair game to slash off. So right here, I'm multiplying. Here I am, even here, and even here, and here. So anything that is separated through multiplication can be crossed off. So probably the ones that jump out at you are this 2x minus 3, this x minus 1, and then this loose x right here could cross off with this loose x right here. And then the 2 is still sitting there. I cannot cross it off with anything because I don't have a loose 2 anywhere. So I think where I'm at is at my answer. I've got an x plus 2 on the top and an x minus 2 on the top. In the denominator, I have a 2 with this x plus 5. And everything else canceled out. Now, when we talk about the domain on these, again, you're not looking at the domain at this stage. You've got to look at the domain up here or after you have factored it. So when I look at this, there are a lot of restrictions. So I would say that the domain on this one, x cannot be, and I'm going to go through each part of the denominator, the x minus 1. Okay, that means I don't want x to equal 1. I don't want it to equal -5. Let's go to the next part. This right here, I wouldn't want it to be 0. And here, if I were to set that equal to 0, I'd add 3, divide by 2. So I don't want it to be a 0, and I don't want it to be a 3/2. You have 4 different restrictions for that problem there. Now, in this one, we're doing division. So it's a similar process, but if you had a fraction and you had, I don't know, 2/7 and you were dividing by, let's say, 4/5. Remember that division, you change it into multiplying by the reciprocal, so 5/4. So I'm going to do the same thing. I'm going to factor, 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 but this division here is going to get turned into multiplication, and then I am going to flip this fraction. All right, I am seeing some cubes here. This looks like a difference of cubes. So that is going to be the cube root, and then let's do the SOPs. Square the first term. Sorry, that should not be cubed right there anymore. It's just an x. Cube root of x cubed is x, minus cube root of 8 is 2. And then you have square the first term, opposite sign, find the product, plus, and square the last term. Denominator. That one is a difference of squares. It factors as those two conjugates, x plus 2, x minus 2. Okay, now I'm going to kind of kill 2 birds with 1 stone here. I am going to go ahead and flip it and factor it in one shot. So I'm going to factor this x cubed plus 8 right here, but instead of having it down in the denominator, I'm going to put it in the numerator. That is going to be an x plus 2, another sum of cubes on this one. Going to look very similar to the other. Square the first term, opposite sign, find the product, plus square the last term. All right, and then I'm going to try to factor this quantity and put it down here. So we're looking for factors of 4 that add up to 2. All right, hopefully you're hesitating here because there are no factors of 4 that will add up to 2, because 2 and 2 add up to 4, 4 and 1 add up to 5. This does not factor. And that might be distressing initially until you take a peek right here. Looky there. That's actually the exact same thing as this. So I am just going to cancel out those big quantities because one's on top and one's in the denominator. Okay, what else can we cross off? Looks like we got x minus 2s can go. We have x plus 2s can go. And all we have left is our trinomial there. So final answer. Remember when you do the cube root SOPs or crummy SOPs, whatever you want to call it, when you do that, the trinomial that's left is never going to be factorable. So don't spend a lot of time trying to factor that SOPs part. It does not factor. Now, this does say that from now on, the domain is implied. So implied means, can we all just agree that we're not going to have any issues with the domain? That's what we're doing. Until we get to that point of actually solving and we really do need that domain, we're going to assume it's implied. We've multiplied, we've divided. Now let's try some addition and subtraction. Okay, so think about this with me. If you have 4/5 plus 2/3, let's think about that. You're adding fractions. What do you got to have? A common denominator. All right, so these two denominators have nothing in common, so the common denominator would be a 15, which means this one is going to get multiplied by 5/5. This one times 3/3. Okay, that's what I'm trying to do, except everything is going to be an algebraic expression. So when I'm looking at what's the common denominator between these two things, well, remember the minus sign ties this together as its own thing. The plus sign ties this all together. So those 3's have nothing to do with one another. These x's have nothing to do with one another. Just like over here, you had to take the 5 times the other denominator, you had to take the 3 times its other denominator. These are the two denominators just multiplied together. So here's my common denominator, x minus 3 and 3x plus 4. Which means over here on the left, I'm going to have to take this fraction times 3x plus 4 so that it'll have that common denominator. And then over here, you've got to take the right side times an x minus 3 so that it will get that common denominator. So I definitely now have this common denominator on both sides. To get the numerator, I'm just going to start messing with all this stuff. This x is going to have to distribute through. So that's going to turn into 3x squared plus 4x. Over here, this 2 is going to distribute. But you have to be really careful of something. This minus sign. This minus sign means I'm going to be subtracting everything after that. So we tend to forget that as that gets longer and longer, we forget that. So I like to do a quick little plus a negative. And instead of distributing a 2, let's distribute a -2. And that way we don't lose track of that negative and it goes on every term. All right, last step is just to clean it up. So 3x squared, I have some like terms there, so plus 2x plus 6 over the common denominator. Now, there is a possibility that this factors. I would only care that it factored if it happened to factor perfectly to one of these, but that happens so rarely, I'm not going to spend a lot of time on that. I'm going to assume that's not factoring for us. All right, this one's a little bit trickier. We've got 3 fractions we're adding, and the thing is I have an x minus 1. It's its own thing. I have an x. It's its own thing. And I have an x squared minus 1. It's its own thing. So none of those exactly match. However, let's come back over here, going back to numbers. What is this, the 5th grade maybe when we did fractions? So let's say you have a 4/9 plus, let's say 7/15. And then we're trying to look for that common denominator. Now, what we did last time is we just took each one times the other. So I would take 9 times the 15 and take 15 times the 9, and whatever 9 times 15 is the common denominator. But we really don't have to do that. We want the least common denominator. And there's a smaller number that 9 and 15 both go into. So 9 is actually a 3 times a 3, where the 15 is a 3 times a 5. So what I need here for a common denominator is I'm going to have a 3. I'm going to have another 3. But this 3 can already be accounted for from the first 3's, but I do need a 5. So 3 times 3 times 5, that's 45. So the common denominator is 45, and I don't have to really build it up with this 3. So let's go look at the algebra. It's the same deal over here. I've got the x minus 1, nothing I can do. Nothing I can do with an x, but this is a difference of squares. And I want to factor my difference of squares. And what I notice when I do that is I have this x minus 1 that's already going to be accounted for over here. So when I look at the 3 separate terms and their denominators, it looks like I am going to need a common denominator that's going to have an x minus 1, and I'm just getting that right here. It's going to have an x. I'm going to tuck that on the front. And then it's going to have an x plus 1, and it's going to have an x minus 1. Well, hang on. I've already got the x minus 1. It's here. I just need an x plus 1. So here is our common denominator. Now, once you decide your common denominator, so over here in my numbers, I decided 45. So then you have to take this times whatever you need to get to the 45. So I'm going to take it times 5 on the top and the bottom. This one, 15 times 3 is 45. So I'm going to do 3 on the top of the bottom because that's what this one's missing. So let's go look over here. If I want this for a denominator, what is this denominator missing? Well, it's missing the x, and it's missing an x plus 1. So that's what I have to multiply by, an x times x plus 1. And I'm going to do it on the top. I'm going to do it on the bottom. Okay, the second term has the x, but it does not have the x minus 1 or the x plus 1. And then I'm going to do that in the denominator as well. That's how I'm getting that common denominator. Okay, last term here has an x plus 1 and has an x minus 1. What it's missing is just the plain old x. So I'm going to take it times x. Now we're going to work on distributing all that through in the numerator and then combining some like terms and reducing. So starting here, I've got an x. I'm probably going to grab this 3 and tuck it on the front end. So it's a 3x. 3x times x, and then 3x times 1. So that's going to get me 3x squared plus 3x. Now for the second term. Now this one's a little bit messy because you have these quantities, and then you also have to take it times 2. Probably the simplest thing to do here would be to go back to where this came from. That's just an x squared minus 1. I would probably FOIL this together, which I already know is going to take me back to x squared minus 1. And so if this is an x squared minus 1, now I'm going to distribute my 2 through that. And actually not my 2, but this is like a negative 2. So let's take a negative 2 and let's distribute it. That's going to get us negative 2x squared and a positive 2. Okay, last term. You've got the x plus 3. You got to take your x times that. It's going to get me an x squared plus a 3x. All right, surely there's some like terms here. Let's see. We've got a 3x squared minus 2x squared, so that's just x squared. 3x and 3x. Oh, hang on a second. I missed this x squared out here at the end. This was 3x squared minus a 2x squared is x squared, but here's another x squared, so it's really going to be a 2x squared plus my 6x plus my 2, all over common denominator. Again, we're going to assume that the numerator doesn't factor to cross something out, but I could do a quick glance at it and say, hey, you know what? There's a GCF here. I could factor the GCF out, and that would be great if I could reduce it with something down here. But factoring a 2 out, I don't have a 2 down here to cross off, so I'm not going to gain anything. Let's not mess with it. There's my answer. All right, so I have done one of each type that you're going to see. What I have here are some practice problems. If you're feeling like, all right, I got this, this is easy peasy, great, run with it. But if you're looking at this like, I need a little bit more practice to get the hang of this, to know what to do when, then I would probably recommend you pause the video. You're going to practice these problems. When you're done, come back and check your answers. But to do that, you're going to have to pause the video right now. All right, I wasn't sure if you were going to go ahead and do the other one, so I went ahead and stopped here. I factored everything and then started slashing. Check your answer here. If you agree, let's keep going. If you don't, then pause the video and find where your error is. Might have been on all the factoring. Okay, then go ahead and when you're ready, pause the video again and work through the second one. All right, again, check and see if you agree. If so, let's keep moving. If not, pause and find your error. I have one more example, so go ahead and practice this next example and pause your video. All right, a couple things that I want to draw your attention to on this one. Did you catch the minus sign there? Got to be careful with that. That's going to distribute to both of those terms in this fraction. The other thing I did is I decided I was missing the x and the x minus 2, but I knew that up on top I was going to want to distribute that. So I went ahead when I wrote it up on top, instead of writing it like this, I went ahead and distributed it. And it kind of saved me from this mess here when I do that. All right. Hope this has helped. Good luck.